Hi everyone. In this video, we'll continue our discussion of integrating mixtures of sine and cosine. In the previous video, we discussed a strategy which suggests looking for the odd power. But in this example, we only have even powers. So there's a different strategy we're going to need in these types of situations. The strategy is to apply what's called a half-angle identity. My guess is that some of you watching this video haven't thought about these identities for a long time, maybe even since high school, so take a moment to write these down on your formula sheet because you're going to need these a lot from this point forward. The reason these are called half-angle identities is because the angle you start with is half of the angle you end up with. Or in other words, the angle gets doubled, going from theta to 2 theta. And keep in mind that theta is just a placeholder for whatever angle we happen to be dealing with. So let's say, for example, our angle was 2x. Then when we apply this identity, the 2x would get doubled and become 4x, as you see here. If that much is understood, let's now go back to our integral and see if we can solve it. To start with, both sine squared and cos squared can be expressed as you see now using these two identities. And after that, notice the 2 times 2 in the denominator could be pulled out as 1 over 4. Then we should expand all this out just to make the integration steps easier. Since we're multiplying conjugates here, we know the inner and outer terms would just cancel, leaving us with 1 minus cos squared of 2x, but you can pause and check that for yourself if necessary. Since we already know how to take the antiderivative of 1, we might as well do that part now. The antiderivative of 1 is x, but we still need to calculate this remaining integral of cos squared of 2x. How should we do that? Well, notice this is another scenario where we have an even power of cosine and no odd powers. So the correct thing to do is to actually apply the half-angle identity again. Pause and see if you're able to apply that identity on your own, and when you're ready, let's check your work. The important thing to notice here is that every time we apply this identity, the angle doubles. So if our angle was 2x, now it becomes 4x. So your integral should look as you see now. After that, we may as well pull out this factor of 1/2, and what remains now is an integral that we actually know how to do just by inspection. So let's do this one term at a time. Start with the antiderivative of 1, which we know is just x. Then we need the antiderivative of cos 4x, which would be 1/4 sine of 4x. As a final step, don't forget the plus c. Further simplification is of course possible, but not really necessary. Now pause and try this one on your own. When you're ready to check your work, let's continue. Since we're dealing with only even powers, we need to use this half-angle identity. But to use it, we need to have sine squared rather than sine to the 4. So as a first step, we should express sine to the 4 as sine squared squared. With that, you're ready to apply this identity, bearing in mind that this entire thing is still getting raised to another power of 2. Notice the 2 squared in the denominator can be pulled out front as 1/4. And after that, we just need to expand everything out. That requires us to use FOIL. Pause and check that you get these results after expanding. Now we're in a position where we know the antiderivative of some of these terms already, so let's just get those ones out of the way. First of all, we know the antiderivative of 1 is just x. Next, by inspection, sine of 2x is the antiderivative of 2 cos of 2x. And the antiderivative of this last term is still not known to us. So how can we figure it out? Well, it's another situation where we have only even powers. So that means another half-angle identity needs to be applied. So let's write down this identity, keeping in mind that the angle once again doubles to become 4x. After pulling the 1/2 in front of your integral, you'll be left with this result, which is an integral that we can now do by inspection. So as always, let's just do this one term at a time. Start with the antiderivative of 1, which we know is just x. Then take the antiderivative of cos 4x, which we know is 1/4 sine of 4x. Make sure to include the plus c and you're done. Although there are typically a lot of details that need checking, the same strategy honestly works in any other situation where you're faced with even powers of sine and cosine, so at this stage all that's left is to practice. That's all for now, so I'll see you next time.